Yeah, what I was saying was this is a good question. Unacademy video architecture, even though the problem statement is similar, it is a one-to-many video call. They do use WebRTC. Well, at least they did until I saw classes like a few years ago. Pretty sure they use the same infrastructure now. So for them, they've made the conscious choice. Let me share my screen here. This is a question from yesterday, like a continuation question from yesterday. They have made the conscious choice, if this is going to be our window that the student sees and the teacher sees, and this is the video, this gets streamed via WebRTC, and the slides most probably get the current slide that you're on, 1 on 10, 2 on 10, wherever, gets most probably streamed via a WebSocket. So whenever an educator, if this is the student screen, let's say, and this is the educator, the educator sort of streams video to an SFU, which most probably forwards it here to the student. But the reason I say most probably is because most probably they have a distributed SFU, which means you're sending it to one server, which distributes it to multiple servers, one of which reaches the student. And the slide that the teacher is on most probably goes through. If they ever change the slide, this goes to a WebSocket server, which then gets transmitted to the slide over here. All other edtechs, PhysicsWallah, for example, they use HLS, and there the latency is higher. PhysicsWallah also has like some small portion which is in WebRTC, but they use an external service called 100ms for it. They have not built it in house. That's a brief. Reshare screen. We'll do it. Don't worry. Let me stop sharing. All right, let me pause. I look at a lot of questions. PR review when? Tomorrow onwards. Not tomorrow. Probably day after onwards. I'm going back to India basically tomorrow, so we'll have more time. Either probably Friday. I would say Friday. Coming Friday is when I can almost commit, but before that, unsure. Solidity or Solana blockchain? Where to start? Very tough choice. Right? It's like asking Python versus JavaScript, or Django versus Express. Wherever you find a company, I guess, where is the higher probability of finding companies? Very hard question. EVM or Ethereum or Solidity comes with its own set of benefits. Okay, you can target a bunch of companies that are EVM. Basically, Ethereum is not the only chain that supports Solidity contracts. A bunch of other chains do. Versus Solana, you're most probably restricted just to Solana. So yeah, if you're a complete beginner, anyways, Rust is going to be very hard. So I would just go with Solidity. WS Rust migrate. Yeah, I've seen that. Need to review it though. But yeah, I've seen the PR for it. Just did not get the time to merge it. Let's see, where did they put it? They put it in apps. Probably not the best place for it. Models, games, main.rs, handle connection. Oh, this doesn't seem like it's complete, is it? Not showing my screen. Never mind. I'll look at it after the class. Maybe on Friday. 8:35 already. As in 7:05 already. I think we can get right into it. Let me share some context for today's video. Today's class is going to be pretty much a continuation of yesterday. The first thing we are going to do is create a simple WebRTC call, which means if you have not gone through yesterday's class, today's class is going to be a little hard. We're going to build a simple P2P video call. Specifically, we're going to build it one way. What do I mean when I say one way? I mean there will be a sender screen /sender who will be able to send video to another user who will be on the /receiver screen, which basically means it's not a two-way call. It is a one-way call from a sender to a receiver. But whatever logic we've added like this, you can just add similar logic on the other side and create a two-way call. I've created a bunch of assignments that you can look at after the class, which pretty much are continuations on top of this. Number one is a single producer can produce to multiple people. Right now, the code that we will write, a single sender will be able to send video to a single receiver. But a very good thing to build on top of it is how can a single sender send video to multiple people. This one should be slightly easier to implement than two-way communication. Then the next assignment would be adding room logic, so that you can have multiple rooms where sender in room 1 is sending data to receivers in room 1, sender in room 2 is sending video to receiver in room 2, so on and so forth. Two-way communication, and then finally replace the P2P logic with SFU logic. This last one is what we will do in the chess repository as well. Most probably not today, but whenever there will be a PR eventually, and maybe I'll create an offline video for it as to how you can add proper SFU logic, proper WebRTC logic, and not just what we're discussing this week. The things that we've discussed is basic WebRTC. This basic WebRTC isn't really used in a Zoom-like call, and you should avoid it even for an Omegle call. You should have an SFU-like architecture. What is an SFU-like architecture? We discussed it yesterday towards the end of it. It's present here in the last slide. But that will be the PR that will be created in the chess repository, and you can shadow it. I will also create a video on it. Today, let's try to build a simple peer-to-peer call just to understand how many of you were in yesterday's class and understood. Were you in yesterday's class and understood everything, yes or no? And if you weren't, then select no. If you did not understand, then also select no. Okay. Decent chunk are from yesterday's class / understood. Well, it's like 60-40. So either way, feel free to drop off if you think everything is going above your head, because there is a prerequisite to today's class, which is yesterday's class. So you should probably go through that first before you get into coding anything today. Let's get right into it. Let me revise one time what we have to do before we dive into the code. This will actually be a little easier when we dive into the code, but let me one more time revise how do two people talk in a simple WebRTC call, the WebRTC call that we are creating today. If this is browser 1 and this is browser 2, and browser 1 is supposed to send video to browser 2, which means this guy is the producer and this guy on the right is the consumer. Whatever video is being captured from this user's camera needs to reach the second browser. The first thing you need to do is create a signaling server. The goal of this signaling server is to establish connection between both the parties. Eventually, both the parties will be talking directly to each other. This is what peer-to-peer stands for, or P2P. But before they can find each other, they need to share some information. They need to share an SDP, a session description protocol, which if you remember from yesterday, the SDP contains your ICE candidates, which are nothing but, the current IP that you're on, and some extra information. Do you want to send audio? Do you want to send video? So on and so forth. This SDP needs to be exchanged between both the parties, which happens through a signaling server. Today we'll be creating this signaling server first. First thing we'll do is create this WebSocket server. Then we will write the client side code. The signaling server needs to support 3 types of messages. It will take 3 types of messages from the users. Number 1 message it will receive from browser 1 would be create offer, which means browser 1 is sending their SDP to browser 2. What does it need to do, the signaling server? It just needs to forward this to browser number 2. That is the first thing our signaling server needs to support, forwarding SDP from browser 1 to browser 2. Then browser 2 will respond back with its own SDP. So the second message that our WebSocket server needs to support is create answer, which is the other side responding back with an SDP. And there is a third message, unfortunately. This should be good enough. If one side created an offer, sent its information to the other side created an answer, sent its information. And this should usually be enough to create a connection between both the sides. But there is something called trickle ICE, which basically means a lot of times your ICE candidates, your IP that I was talking about, 2.2.3.4 some port number, these candidates slowly trickle in, which means when you create the initial SDP, it doesn't have your ICE candidates. You have to eventually send them whenever you receive them from the stun server. What is the stun server? We discussed yesterday. So basically we need to support one third message. The third message is called add ICE candidate. Whenever the first side receives an ICE candidate, it needs to tell the other side, and vice versa. Whenever browser 2 receives an ICE candidate from its stun server, browser 2 also needs to forward the ICE candidate to browser 1. So both the sides will use the third message, but the first message is used to send information from browser 1 over to browser 2. The second message is used to send information from browser 2 over to browser 1. And the third message, add ICE candidates, is used by both the sides. Sometimes this side will send data to the other side. Sometimes this side will send data to the other side. What is the use case of the third message? A lot of times the browser will get back its ICE candidates from the stun server. If you remember, there is a stun server here that both the parties will use. It will slowly get it back. And if it gets it back after some time, let's say 5 seconds, it needs to tell the other side, hey, this is another ICE candidate for you to try. If you can't find me until now from the existing list that I sent over here, here is another ICE candidate. Please try if you can connect with me here, which is why we need to support this third message. If you go through the following repository that we had used in the past, Omegle, that we had created in a live stream, if you go to the backend code, backend/source/index.ts, maybe not source/index.ts, but managers/user-manager.ts, you will see there are 3 types of messages that we expect from users: an offer message, an answer message, and an ICE candidate, add ICE candidate message. We are creating something very similar. We need to support these 3 types of messages from the end users. The user will either send us their offer, or the other user will respond back with an answer, or either of the parties will be sending us their ICE candidates. The code that we'll be writing today, if you understand that, you should be able to understand this Omegle repository fairly well, which is something we created during a live stream, which created a Omegle-like two-way communication app. With that context, let's get into the code and try to slowly build what we're building today, which is a one-way communication application. What do I mean by one way? I mean browser 1 will send video to browser 2. Browser 2 will not be sending video back to browser 1. Let's start by coding the signaling server. What is the implementation? We will be writing the code in Node.js for the signaling server. It will be a WebSocket server that will support 3 types of messages: create offer, create answer, add ICE candidate. And we'll also be writing the React code, which will involve the peer connection object. If you remember from yesterday, basically some heavy WebRTC API that we'll be writing on the front end. Let's begin with writing the backend first. What we are writing is nothing but a signaled version of this JS fiddle. If you look at this JS fiddle, it lets you create a WebRTC session and send a video from this browser to this browser. Rather than sending video from the browser to the same browser, we are going to signal it, which means we are going to send it between 2 different browsers. But if you look at the final client side code, it will look very similar to what you see in this JS fiddle, but you can look at it later on after the class. Let's start by creating the backend. If you want to code along, would urge you to code along and write at least the backend yourself. The backend requires no WebRTC logic. The backend just needs to support 3 types of messages. Here, whenever one user creates an offer, send it to the other side. Whenever other side responds, send it to the original side. And then when either of the parties tells you add ICE candidate, forward it to the other side. So this is something you can write without any WebRTC knowledge as well. So try to write this yourself, or all the code is here, so feel free to copy as well. First, let's create a simple Node.js project. The way to do that is create a folder wherever you want to write all of your code for today. I'm going to write it in WebRTC week 23. Open this in Visual Studio Code. and let's go from there. Let's create a backend folder here first, because this will have both the backend and the front end for our application. And inside this, initialize a TypeScript project, which we have done many times now. So I'm hoping it's very easy for you to know how to do it. npx tsc or npm init-y to initialize a package.json, and npx tsc-init to initialize a tsconfig.json. Both of these commands are already present here in the slides, so feel free to look at the slides as well. These are the two commands that I've run until now. What is the third command to run? Maybe before the third command, I should change the root dir and the out dir in tsconfig.json. Root dir to be /src and then out dir to be /dist. This is standard bootstrapping that we do for a TypeScript application, so that the input code is taken from the source folder src and the output JavaScript is put in the dist folder. Lastly, create a source/index.ts file where we'll be putting all of our code for today. That is the brief of bootstrapping the backend, and I'm hoping this is straightforward. The next thing is adding the WS library to your backend, because since I said this will be a WebSocket server, you need to have the WS library, or you can use a different WebSocket library. Why does it need to be a WebSocket server? Because we need to send messages from one side over to the other side. The signaling server needs to push events to the other side. And whenever you have to push events, WebSocket is a common protocol you use. You don't use HTTP, because then browser 2 will have to poll the message, versus if you want to push a message from the server, WebSockets are the common protocol to use. Lastly, we need to write the code for our WebSocket server. Import WS from WS or whatever that the API is. Create server. Totally forgot the API. Thankfully, it's already written here, but also, feel free to look at the npm docs and figure it out from there. This is how you create a simple WebSocket server. This is just an example from npm.js. So if you go to the official docs of this library, you'll reach the same example, which lets you create a simple WebSocket server. I import WebSocket server from the WS library that I had just installed here. Then I initialize the WebSocket server. I have created two local global variables here. I repeat, two global variables that I will eventually assign inside this specific callback. But for now, feel free to ignore these two. Ignore the two variables that I've created. WebSocket server.on connection. Anytime there is a connection, let me simplify this even further. Anytime there is a connection, you get a WebSocket instance, and anytime a message is sent on that WebSocket, on that specific socket, control reaches here. Let me log this message. This is a simple WebSocket server, has no logic to do whatever we have in this diagram yet, but this will just bootstrap a WebSocket server. How do we know it is working? If I run tsc-b to compile my code, you will see dist/index.js is created. If I run node dist/index.js, you will notice a WebSocket server has been started. How do I know a WebSocket server is started? I can go to hopscotch over here. This is something we discussed in the WebSocket class, so I'm assuming it's straightforward. I can go to the real-time section over here, type in the URL of my server, click on connect, and if it says connected, means we are good to go. If I type a message here and click on send, that message should have been received over here. It did get received, but since this is not valid JSON, my backend crashed. If I do make this valid JSON, then it should be fine. Let me try that one more time. Connect and then send, and you will see whatever valid JSON I sent over here is getting logged over here. That is how you create a simple WebSocket server. Now we need to support three types of messages here. We need to support a create offer message, a create answer message, and a add ice annotate message. These three messages we need to support. But before that, we need both the parties to identify themselves. I repeat, we are creating a very simple, crude application where we expect two people to come, a sender and a receiver, which means our final front end will have a localhost :5173 / sender route, and then it will also have a receiver route. Whenever the sender comes, the sender needs to tell the WebSocket server, hey, I am the sender. I will be sending the create offer message. So please expect that message from me, which means other than these three messages, we need to support two more messages. Sender, or identify as sender, and then identify as receiver. The first message will be sent from the /sender page. The second message will be sent from the /receiver page. These are the 5 messages we need to support. To make sure we have a local copy of the sender and the receiver socket, which means this socket right here, I created the 2 global variables that I removed a while back. Let sender socket equal to null. Let receiver socket equal to null. Notice this application will only support a single browser on the left, a single browser on the right. You cannot have multiple senders and multiple receivers right now. Very plain application to support a single sender and a single receiver. To store their sockets globally, I create these global variables. Why do I need to create them? Because whenever the create offer message comes, I need to send this message to the receiver socket. Whenever the create answer message comes, I need to send it to the sender socket. So I'm caching them globally here, which basically means if message.type is identify as sender, then I will set the sender socket to be this thing right here. Else if the message.type is identify as receiver, I will set the receiver socket to be this. That way I have the actual socket available globally, so that whenever the create offer message comes, whenever this first message comes, I know where to send it. Where do I need to send it? To the receiver socket, which means receiver socket dot send something like this. Okay, hey, this is the offer that the original party sent to you. It will give you a TypeScript error here because we haven't given it any type. Feel free to give it an any type, or if you want more strict types, you can put something like this as well, null or WebSocket, where WebSocket comes from here. That is a brief of how we'll be building our backend. I'm hoping the first 4 endpoints at least are slowly getting straightforward. One side will create an offer, we forward it to the other side will create an answer, and we forward it to the original side. I added a question mark over here because TypeScript was complaining that hey, receiver socket can be null, so you can't really call .send. So I add a question mark here, which stands for optional chaining. If it exists, then call .send. If it doesn't exist, then don't throw an error, just move on. If you want to do a cleaner thing here, you can do something like this. If not receiver socket, then return. This works as well. Or you can add a question mark over here, just like I did. That is the brief of the first 4 messages. There is one more message to add, but I will take a pause here just to see how we're doing. And do we understand a brief of the backend code? If you look at the slides over here, the code looks fairly similar. ws.onMessage, parse the message, and then if the type is sender, then you set the sender socket to be WS, receiver, then receiver socket to be WS. If the message is create offer, we first make sure okay, this is the sender socket only. The other side is not trying to send it. Feel free to ignore this as well. And then we send it to the other side, and then vice versa. If the other side is responding with an answer, we send this to the original side. Basically, this message right here and this message right here. The only message that is left is this last message. Whenever the either party gets an ICE candidate, here what do we have to do? Here, if the sender socket sent us ICE candidate, we need to send it to the receiver socket. And if the receiver socket sent us ICE candidate, then we need to send it to the sender socket. We need to take message from one side and forward it to the other side. And then there is the actual message that we're sending. The first message needs to forward the SDP. So does the second message. The last message needs to forward the candidate. Of course, we will finally look at the front end code that actually sends the message, and we'll see the body that we're sending there. But let me take a pause here. Do we understand this simple WebSocket server? That is all you need on your signaling server. You don't need anything extra. Rest of the logic will be on the front end. That's all that the WebSocket server needs to do. Just forward messages between both the parties until they can directly connect with each other and talk to each other. All right, sort of understand it. 74%. So great for the people who do understand it. Next slide has the code for the front end. Try to write this front end. More specifically, try to understand all the code that's written here. There's a lot of code here. Let me take questions for the next 7 minutes, because 75 is not the best ratio, and then we'll go from there. But yeah, next up we need to write the front end for it. All right. I have created a dot in. Okay, seems unrelated to this class for now. Any questions related to what we've done until now? Sender socket equal to WS. Explain or go a bit slow. Recap. Alrighty. Let's look at the code one more time. Let me copy all the code here. Let's go from top to bottom. What needs to happen eventually? If you look at the diagram, browser 1 needs to send a message to browser 2, and browser 2 needs to send a message to browser 1. And there is a third message that either of the browsers can send. This can send to this side, or this can send to this side. Which means whenever I receive a message that says create offer, I need to send it to the other side. I need this socket variable to be present somewhere, right? I need to I need to send this message from the signaling server to the other side, which means this WS variable for the other side needs to be cached somewhere globally. This WS variable is how you can send a message to the other side. If I remove all of this logic and I simply do set timeout or set interval, every 1 second, do a ws.send hello world. If I write this code, what does this code say? It says here, anytime someone creates a connection, we will send them a message every 1 second. So they will keep receiving messages from us that say hello world every 1 second. Let's try to now start this server and connect to it. If I start this server and connect to this specific server using hopscotch, you will see after I connect to it, I am receiving the hello world message every 1 second. Every 1 second I receive message, which means this is how you send a message to the other side. This is how you send a message to a WebSocket client. This is the WebSocket client. It connected to the server. Control reached here. And this is how I'm sending it back a message every 1 second. Now the problem is, if another user connects, if I go to another tab and another user connects, this user is also receiving hello world. This user, for this user also, control reached here, and for the WS instance of this user, we are sending this user message. Same is happening for this user. Now, if I need to send a message from this browser over to this browser, I need to cache the individual socket variables, which is why I'm caching them globally here in the sender socket and the receiver socket. I'm saying, hey, whenever you connect, let me know, are you the sender or are you the receiver? And if you are the sender, I will cache your WS variable here in the sender socket. If you are the receiver, I will cache your WS variable in this receiver socket, so that in the future, if ever this party sends me a message, I know where to forward it. If ever this party sends me a message, I know I need to forward it here. So we are just storing this WS variable globally so that it can be used later on whenever one party sends the message to send that message or forward that message to the other side. This is a crude way to store it. Would have been better if we do better state management. And if you want to look at how to do better state management, you should look at the Omegle code that I pointed to beginning of the class. That pretty much, creates a user manager class inside which we do all of this logic. We don't have global variables there. That is probably also the right way to do it. This is just for understanding a simple example between two peers. So again, to recap, what have we done? We initialized a WebSocket server and we said, whenever someone tells us they are the sender, we are going to take their WS instance, socket instance, and store it here globally. Whenever someone says they're the receiver, we're going to take their socket instance and store it here. And now, if create offer message comes, I know it came from the sender only. The sender is the one that will be sending this message, right? If you look at it here, browser 1 is what sends the create offer message. So I'm going to forward it to the receiver socket. Where was this variable set? It was set over here whenever the receiver told us that they are the receiver. And vice versa. Whenever create answer happens, we send it to the original side. And then lastly, this message may, if the message is sent by the sender socket, we send it to the receiver socket and vice versa. So that is how we have bootstrapped our server. Do we understand it now? Switch case makes more sense here. Yes, you don't need so many if else's. You should use the switch statement. Sir, why are we explicitly checking message.type equal to identify sender? Shouldn't one be creating the offer be identified as sender? Yeah, just for clarity, if I'm being honest, sure, you can just do it here. Whenever you receive a create offer message, you can be like, sender socket equal to WS. And then here, whenever they respond, but you don't know what the receiver socket is. Like basically, to avoid complications, I've done this. Sure, you can, find a way to not store this globally and do like a cleaner approach. What's the difference between WebRTC and HLS? What is used in industry like Google Meet? Okay, we answered this yesterday. I'll give you a brief. For a two-way call, which means Google Meet or Zoom, you have to use WebRTC. For a streaming use case, something like video live streaming on YouTube, you use HLS. Property dispatch message. If you have that error, you haven't imported WebSocket from the WS library. You are using WebSocket. You're using this type from the global WebSocket object. Don't use that. Import WebSocket from this specific WS library. Then that type error should go away. All right. 85%, pretty decent, which means I'm assuming we are going to proceed now. Of course, we'll take doubts at the end of the class. Backend code is done. Front-end code is going to be heavy. We discussed the front-end code a little bit yesterday, but I'm going to repeat this again and again. WebRTC APIs are very convoluted, which means, you have to write a lot of code, which sounds or looks very weird, or / you've never done it before. So yeah, this will be tough, but we'll try to spend a lot of time here and understand it. But yeah, this is supposed to be tough. Let's initialize a front-end repository. So I'm going to go back to my Visual Studio Code. I have my backend working and running. So I'm going to go back a folder and then initialize a front-end folder. How do I do that? First, I go to the root folder, WebRTC week 23, and then I type npm create @latest. This is how we've been initializing React projects over and over. Harkirat, why React? Why not Next? Doesn't matter, API remains the same. So, you can choose either. This is just easier to write. Choose React as the framework, choose TypeScript as the language, and you should have a basic React project bootstrapped over here. The first thing you should do whenever you have a front-end application is add the routes. We will need 2 routes, as I said yesterday, or like a while back, localhost :5173/sender and then localhost :5173/receiver. These are the 2 pages that we need to support. And hence we need to first add React router DOM to our project, which is this library right here, by doing an npm install React router DOM. So let's do that first. And then we need to, I'm in the right folder. And then we need to add basic routing, which, if you've gone through the class of routing, this is straightforward. You create a browser router, you have two routes. If the user comes to /sender, they go to the sender component right here. If the user comes to /receiver, they go to the receiver component right here. That is the basic routing logic. Of course, we need to define this specific component in this folder and receiver component in this folder. But first, let's add this specific logic in app.tsx. So go to app.tsx. It will have like a lot of code, which is like basic bootstrapping code. Replace it with all this code over here, which has the routing, and then add your components /sender and components /receiver. So if I go to front end source, this has app.tsx. It is expecting a component over here. So let's add that components /sender.tsx and then components /receiver.tsx. Both of them should export something. So export const sender equal to, you can also do something simpler. Sender and then receiver. And now all the errors should go away. What have I done? In app.tsx, after bootstrapping the application, I added very basic routing over here. And I have two routes, /sender and /receiver. /sender takes the user to the sender component. /receiver takes the user to the receiver component. If I run npm run dev over here and go to localhost 5173 /sender, I see sender written in the center of my screen. If I go to /receiver, I see receiver, which means routing works as expected. We have the two pages set up correctly. Now I need to make sure that whenever I'm in the sender, I first tell the server what? I tell the server, hey, I am the sender, which means I send the server this sender message. I will of course eventually send all the other WebRTC messages, but to begin with, I need to tell the server, hey, I am the sender of this message. So I need to, in sender.tsx, if you look at the code over here, let's just write it from scratch slowly. Let's not look at the code, even though this is the final code that is needed. Let's try to slowly build towards it and not, look at the very long file that we have. What is the first thing I need to do? Create a socket connection to the server. How can I do it? I can create a top level effect which runs when the component mounts. And here I can say const socket equal to new WebSocket with the URL to my WebSocket server, which this URL is right. This is the same URL I had put on HopSpot. This is the same URL I need locally. Next thing I need to do is socket.onOpen. When the socket opens is when I should send the message, which looks something like this. Type sender. Harkirat, why did you need this? Because if you try to send it before the socket is open, it will throw an error. So you have to wait for the onOpen callback to trigger. Whenever the connection is actually made, this specific callback will trigger, and then we can do a socket.send. Hey, I am the sender of this specific video call. I'll be sending you the video, or I'll be sending you the create offer message. That is what this side needs to do. And what does the receiver need to do? Can you guess? Pretty much the opposite of it, right? It needs to tell the server, hey, I am the receiver of this specific, video call. Do we understand this much? Do we understand starting the WebSocket connection and then sending the backend, hey, I am the sender and I am the receiver? Now we'll be writing some WebRTC logic. But before we reach the WebRTC logic of create offer, create answer, we need to identify ourselves to the backend server. All right, we understand this. What is the next thing that needs to happen? Let's say we wait for the user to click on a button before they send the video. You can also do this here inside the effect, but let's make it slightly cleaner. Let's create a button, and when the user clicks on the button is when we actually create the offer, create the answer, do all the WebRTC stuff. On the receiver side, we can create a button, but let's not do that just yet. The receiver side basically doesn't need a trigger. That's why the trigger for the receiver side is whenever you receive an offer. I repeat, whenever it receives an offer is when it knows it needs to start doing the WebRTC stuff and respond back with the answer. So we don't need a button here, but let's put a button on the browser one so that the browser one initiates opening the camera and sending the video and everything around it. So I've created a button. One thing I should do before I proceed is put this socket variable in a state variable, because I will eventually be needing it somewhere here in the callback. So button on click equal to start sending video, which is a function I can define here. And here is where I need to write all the WebRTC logic. What is the WebRTC logic? If you remember, we first have to create an offer. That was the first thing you have to do. And if you remember the steps from yesterday, let me go back to the steps from yesterday. What were the steps? Browser one creates a RTC peer connection. So the first thing that browser one needs to do is create an instance of the RTC peer connection. What is RTC peer connection, Harkirat? This is a simple WebRTC object on the front end that gives you access to the offer, the SDP, the video streams that you have, the audio streams that you want to send. It's a high level API to do WebRTC things. Just how we have in the past seen high level APIs like fetch to send a request to the backend, or WebSocket to create a WebSocket connection. Peer connection object, or sorry, RTC peer connection object, this thing right here, is also a high level API to generate a bunch of WebRTC things. Some of these things being the offer and the answer, things like these. The first thing, create an instance of this, const PC equal to new RTC peer connection. This is the first thing you have to do. What is the next thing? Browser one creates an offer. So create an offer over here, which you can do by const offer equal to await PC dot create offer. Await only allowed. This should be an async function. Let me make this slightly bigger. What have I done? Step one is done. Create the RTC peer connection object. Offer is created. Browser one sets the local description to be the offer. This one is important. This one is something that, feels like it's redundant and you don't need it, but you do need it. You need to do a PC dot set local description to be the offer. You're telling your local peer connection object, okay, hey, this is the SDP that I'm sending. If you ever log this offer, you will see what it says and it will pretty much give you the SDP, the thing that you need to send to the other side. Step 4, browser one sends the offer to the other side through the signaling server. Is this straightforward? Do we know this? Socket dot send JSON dot stringify type equal to create offer and SDP equal to, you can either do PC dot local description, or you can also do the offer over here because we already have the offer, or PC dot local description, since we've already set it over here, will pretty much contain the same thing. This last message is what we just created a handler for in the backend. If you remember the backend, the create offer message is what was expected here. If message dot type equal to create offer, then we send to the receiver socket the create offer message. Of course, we'll create the handler of it on the other side very soon. But do we understand how we are sending the SDP here and how our backend server is forwarding it to the receiver socket? How we have done the first 1, 2, 3, 4 steps. 5th step we need to write on the other side. But do we understand the first 4 steps? Again, this is the code. Dot send. There we go. Cool. Let's proceed a bit and then I will look at Q&A. Just show the backend. Vishnu, why is that wrong? Never mind. Small recap. Oh yeah, that's before. All right. What is the next step? Now we need to go to the other browser. What have we done? We have done this part. Browser 1 has created an offer and let the other side know. Now the other side needs to create a peer connection object, create the answer and respond back to the first side. So what code do we need to write now? We need to write the receiver side code. So let's go to the receiver.tsx. We are slowly building up. We can also write the whole code together, but let's slowly build both the sides step by step. Here, what do we need to do? Here, whenever socket.on, whenever we receive a message from the backend, then we need to do certain things. Const message equal to json.parse event.data. And if the message that's coming in is create offer, let's ignore everything else. Then what do I need to do? Browser 2 receives the offer from the signaling server. That is exactly what happens here. Okay, socket.on message in the receiver. Whenever I receive a message, if it is of type create offer, what do I need to do? Browser 2 sets the remote description to be the offer. Browser 2 now needs to initialize a peer connection object, const pc equal to new RTC peer connection. And this guy first needs to set the remote description. Okay, this is the offer that I received from the other side. This is my remote description. This is the description of the other side. And now I need to create an answer. Const answer equal to await pc.create answer. And then I need to set the local description to be the answer and let the other side know. If you look at it, browser 2 creates the answer, browser 2 sets the local description to be the answer, and then browser 2 sends the answer to the other side through the signaling server. So what does browser 2 need to do now? It needs to do pretty much this socket.send create answer, and this is my local description. This guy is now responding back to the original message with their answer. If you look at the graph one more time, what was it? Browser 1 will send a message which will be caught by browser 2. Browser 2 will do some WebRTC things and then respond back with the answer that now browser 1 needs to catch. So we have done this part and we have done this part. We have sent over an offer. We have received an answer. Now I need to catch this answer on the sender side. Socket.send, this thing will reach over here and then it will send the message to the original sender, and the sender now needs to catch this message. So I need to write some code over here. Socket.on message. We can actually write it here. So we can use this PC object without putting it on state. If not, socket return, just to get rid of TypeScript errors. Socket.on message equal to event, const data equal to json.parse event.data, and then if data.type equal to create answer, then what do I need to do? Set remote description to be data.stb. Now this side, browser 1 receives the answer and sets the remote description to be that answer. This is enough to create a connection between both the sides. From step 1 to step 10, we have done everything. We have created a server that lets us relay messages between both the parties. We have written a sender, which when you click on this button, it calls the start sending video function, which creates an RTC peer connection, which is the first step right here. Creates an offer. What is an offer? It is the SDP of this user. It is the, here are my ICE candidates. Here are the messages I'm sending. All the information that lets the other party connect to me. I create the offer. I set my local description to be the offer, which is this step right here. What's the next step? Send the message to the other side, which is exactly what we've done over here. Then what happens? This message create offer reaches index.ts over here. And what does it do? It forwards it to the other side. Receiver socket.send create offer. Where does this go? It goes to receiver. And what have we done in the receiver? Okay, anytime a message comes, we parse the message. In case the message.type is create offer, we first create an RTC peer connection object. That should be a step here. Then browser 2 sets the remote description to be the offer. We set the other side's description is this. Here is how I can find the other side. I create the answer, which is this step right here. I set my local description and then I respond back to the other side. Hey, this is my local description. This again reaches index.ts, the backend server. It reaches over here. It responds back to the sender socket, which gets the message over here and then sets the remote description. This establishes the connection. Now you can kill your server, your backend server. The connection will still remain. This has initiated a peer-to-peer connection between both the parties. You had to do this much to initiate a peer-to-peer connection. We haven't yet discussed the other thing we have to do. We will very soon. But if you are lucky and you get all the ICE candidates in the first go, then this much is good enough. You can create an offer and create an answer. Do we understand this? We will also now try this and see if the connection is made. We haven't yet sent any video, but we will be able to see at least a connection is created between both the sides. All right, we understand this sort of 85%. Try to run this. There will be some problems here. Most probably the connection won't be created, but let's see what happens. Let's log something in the backend. Let me go to the backend and let me log a few things. Console.log sender set, console.log receiver set, offer received, answer received, and then lastly, let's ignore the last message. Let's see if anything gets logged on the backend. If I restart the backend over here, and let me go to sender, let me go to /receiver. When I go to sender and receiver, if you look at the logs, it says sender set, receiver set. It says it twice. Why? Because if you remember, we are in strict mode, which runs all the effects twice. So the use effect that we have over here, even though it says an empty array, it runs twice. So you can either remove react.strict mode or even just keep it. It'll still work. But yeah, let's get rid of it. And now let's see what happens when I restart the application. Sender is set, receiver is set. What happens when I click on send video? Nothing happens. Create offer never reached here. Let's go back to sender.tsx. What did I do when the button was clicked? I called this function and I'm sure someone sees something. Let me open Q&A. Where is the stun server? Do we need to hit that? By default, if you can put that here, basically, stun somewhere here. You can put a property, stun server. Yeah, just Google it. You can pass it as an argument. If you don't pass anything, you get a default stun server. Most probably the Google one, I think. Set socket. I have not called set socket. Thank you, sir. I have not called set socket over here. So, it returned right here. Let me set the socket. And then let's try that one more time. Refresh, send video. You will see it says offer received and answer received, which means first party sent message to the other side. Second party responded as well. Let's go to about:/WebRTC. You will see 2 peer connections have been created. They're still not connected because ICE candidates weren't found. As I said, you have to do some ICE there is a third message we haven't yet done anything with. But you can see 2 peer connections have been created. Both the parties have set local description, have set remote description called. If you look here, set remote description is called first and then set local description is called. This doesn't have any ICE candidates, which is why, the connection wasn't made, which is why we need the third message over here as well, add ICE candidates. but at least we're getting there. We have created a WebSocket, a WebRTC connection on either side. Now let's write some more code. Let's support the third message that we had. What was the third message? Here, anytime a new ICE and candidate comes, I need to send it to the other side, and vice versa. If the other side receives one, it will send me back. How do I know that a new ICE candidate has been added? Thankfully, this PC object returns you a PC.onIceCandidate event, which will get triggered anytime a new ICE candidate is added. If e.candidate, a lot of times this returns null as well, which is why you have to do this check. Then socket.send ICE candidate to the other side. That's all the code you had to write. Let me also log this event here. So whenever it comes, we'll be able to see it in the logs. This is how you can support the third message. Thankfully, the WebRTC API itself tells you, okay, hey, we just received another ICE candidate, send it to the other side. So the other side can do it. If you look at the JS fiddle that I showed you a while back, over there also you will notice an on ICE candidate message. Okay, hey, whenever an ICE candidate is added on the first peer connection, add it to the second one, and vice versa. Whenever an ICE candidate is received on the second message, second peer connection, send it to the first one. Here they're doing it locally. We are doing it over the internet, or over a socket. I need to add the same thing to the other side as well. This is the sender. On the receiver as well, anytime a new ICE candidate is made on the receiver, I need to tell it to the other side. I also need to catch this message on either of the sides. I've written the logic to send the message, but I've never written the logic to actually catch the message. Where can I do that? In socket.onMessage. Else if data.type equal to ICE candidate. If the other side told me that they have added an ICE candidate, I will set it on my peer connection by saying pc.addIceCandidate. I hope that's clear. When you call pc.IceCandidate, it means I've received an ICE candidate from the other side. I'm going to shove it on my peer connection object so that it has another ICE candidate to try connecting to the other side. Right now, if you remembered, when I opened about:WebRTC, if you looked at the local description and remote description, there were no ICE candidates over here, which means ICE candidates are slowly trickling in. This is called trickle ICE. That ICE candidates are slowly trickling in. When they come on one side, we send a message to the other side so that the other side, for example, if this is the sender, if it receives an ICE candidate, it lets the receiver know, okay, hey, else if message.type, it lets the receiver know, okay, hey, a new ICE candidate needs to be added. The problem here is we need to set PC somewhere in the state. Let's do this. Just make it any for now. There you go. Oh no, it's still listener. What am I missing here? Someone tell. Okay, I'll come back to this. I'm sure it's something fairly simple I'm missing over here. Yeah, there's a cleaner way to do it. Most probably the one in slides is slightly cleaner. But what have I done? I'm just caching the peer connection object here so that the other message can call pc.ice add ICE candidate. If I initialize it here, it pretty much gets, I cannot use the same object over here, which is why I just put it in a global variable. There should be a cleaner way to do it in the slides as well. Alrighty, most probably I propagated it here in state in the slides. What have I done? I've told both the sides, here if you receive an ICE candidate, let the other side know. And what have I done on the other side? Here if the other side sends you an ICE candidate, please call pc.addIceCandidate. vice versa. If here an ICE candidate is received, I send it over the socket to the other side, and the other side will call pc.add_ICE_candidate. Now let's see if both the sides connect or not. Still, we have not sent any video. We're just trying to connect both the sides. If I close both the pages and restart them, click on send video, and now you will see the signaling state is stable. ICE candidate pair is still not connected. Connection is still new. Let's see. Nothing got logged. Missing something obvious here. Let me open Q&A. What am I missing? It's not ICE candidate, it's ICE-candidate. All right, thank you, sir. Opening Q&A again. What am I missing again? Create RTC connection outside the block. We cannot do that, then it will reinitialize it. All right, seems like this event is not getting logged. Oh, on ICE candidate. Is this right? Looks right. Let's go to the JS fiddle. pc.on ICE candidate. Yeah, most probably it's not asking for the ICE candidates until you have some data to send. That is my guess. Yeah, this looks right. So basically what is happening is the control is never reaching here. Most probably it is not reaching here because we are not yet sending any data. We have not created any video or audio to send to the other side. And this should re-trigger, or this should trigger when you actually have some data to send, if there is any need for the connection to be made. So let's try to send video from one side to the other side and see if that fixes it. One more thing that we're doing sort of wrong over here is, when I call the start sending video function, I immediately create the offer and send it to the other side. But ideally what you should do is, let me move this up. This logic, right? These 3 lines of code to create the offer and send to the other side should happen whenever negotiation is needed between both the sides. I repeat, I said the first side will create an offer and send to the other side, and the other side will respond with the answer. But you have to keep doing this again and again. This is not a one-time thing. As you add a video, the SDP changes. If you remember the SDP, it had various sections. If you go back to the slide which has SDP as one of the jargons, it looks like this. Whenever you add a video, the SDP changes, which means you have to keep sending it. If, let's say, midway through the call, I add another video, I start sharing my screen, a new section gets added over here, which means you need to renegotiate. You need to resend the offer, get back the answer. So the thing that I've done here is actually not right. You should call this again and again anytime pc.on negotiation needed. Anytime you need to negotiate with the other side, you should create the offer, let the other side know, and then of course the other side will respond back and you will get back the answer. This is slightly better. This might have been one of the reasons connections wasn't made. Most probably isn't. But let's see. Let's save this. What is the change that I made? I just called these 3 lines of code after this callback is called, and this can happen more than once. Let's also log this. On negotiation needed. Let's go back here, refresh, send video. On negotiation needed is never called because you're not sending any video. Let's try to send some video, and then on negotiation needed will get called because you added something to the SDP, and then that should, most probably start this and also start the ICE candidate gathering. Let's add the logic to actually open someone's camera and, send the video from one side to the other side. For that, let me add another function here, or, you can do it directly here as well. Doesn't matter. It's not a lot of lines of code, so directly here is also fine. At the end of the start sending video function after I've done all of the WebRTC logic and all of the socket handlers. I'm adding one more thing, const stream equal to await navigator.mediadevices.get user media video true audio false. It means get me the video of the user, no need to open their mic. If you send audio true as well, then of course it will open the mic. Eventually you should send, both video and audio if you want to create a real call, but we're just sending video for now, which is why this specific line of code, navigator.mediadevices.get user media video true, triggers number one, a pop-up here. The user needs to allow the video. And then number two, if the user does allow the video, it gives you back a stream object right here. If I copy this code and go to google.com and paste the same code here in the console, it will feel like Google is trying to access my camera. As you can see, it asks me Google wants to access your camera, which is why, this specific line of code is what you write in any website to get the user's camera. A lot of times you need the camera just locally. You don't need the camera feed to go over WebRTC anywhere, irrespective of whatever use case you have. Maybe you just have, a website where someone can come and look at their face. This is the API that you call inside the browser to access their camera. So that is the first line of code you need to add. And then all you have to do is pc.addTrack stream.get video tracks of 0. This is all that you have to do. This is probably the most powerful thing of WebRTC. Okay, once you've done all the heavy lifting of connecting both the sides, the WebRTC API is so clean. The PC object is so clean. Okay, all you have to do is call pc.addTrack and pass in the video track that you want to send to the other side, which you can get from stream.get video tracks of 0. A lot of times, you can ask, this can basically return you multiple video tracks as well, but the 0th one is what it will return. In this case, I only have, even though I have two cameras, it will just return one track, and that is how I get the very first track over here. And calling this much is enough to send it to the other side. On the other side, also you have to write something. On the receiver side, you have to write pc.onTrack equal to, let me just log the track for now, but eventually you can use this track to actually attach it to a video element and play the video as well. But for now, let me just log the track that I receive from the other side. Notice I don't have to send this track via signaling. I don't have to do any signaling logic anymore. I don't have to send this to a socket server that will relay it to the other side. I simply call pc.addTrack. This will trigger an on negotiation needed, which will update the SDP, which you will send to the other side. And the other side will know that video is going to come from this specific port or this specific IP. Let's see how this performs now. Let's see, does on negotiation needed get added? Let's see, is my camera device popped up whenever this specific code runs? Let's refresh receiver and sender. Let's click on send video. I do see my camera pop up over here. If I click on inspect, click on console, I do see on negotiation needed. If I go to the other side, click on inspect, go to the console, I don't see a track over here yet. So there is some more debugging for us to do. If I refresh this, I only see a single peer connection. I don't see two, which means, nothing happened over here. The receiver pretty much never got back a message from the sender, even though on negotiation needed was called. So we'll have to see what the error is. This also got logged now on ICE candidate, which means, we're pretty much good to go. Most probably there is some small, let's see, let's try that one more time. Most probably, the receiver might be in some other browser tab. Let's click on send video. Let's open the receiver, open the console. Yeah, there you go. I get back the ICE candidates. I do get back the track as well, basically. Yeah, most probably this is done. If I go to the WebRTC internals, if I open localhost 5173, you will see I'm sending out video over here, which is, whatever, 30 frames per second and has some width, has some height, 500 cross 600. And if I open the other object over here, you'll see it has a inbound RTP, which means, incoming video, which is also coming at, whatever, 30 FPS. So the other browser is receiving the video. I haven't, of course, put it here somewhere, which is very easy to do. But this guy is able to receive video. We can confirm that by looking at the WebRTC stats. To recap everything now, what did we do? Pretty much did what's written in the steps over here. So this is probably the cleanest place for you to look at. Browser 1 created an RTC peer connection object. Happened over here when you click on the start sending video button. Browser 1 creates the offer. Now we are now creating the offer inside the pc.on negotiation name. This is the only extra thing that we added other than what's mentioned in the slides. Okay, whenever renegotiation is needed, whenever both the parties need to re-exchange their offers and answers, is when the offer should be recreated and should be sent over to the other side. And the other side will, of course, respond back with the answer as well. So that's slightly different from what's mentioned here, but pretty close still. Why do negotiation keeps happening again and again? Because you might add more video. Right now I've only called add track once. I might add audio track as well. I might add my screen share track as well. So as you call add track more and more, this function needs to rerun and both the parties need to renegotiate, which is why this logic has been put inside this function. pc.on ICE candidate. Whenever an ICE candidate is received, let the other party know that the ICE candidate is received. This is also not mentioned in the slides, but something you have to do. You can also, add a set timeout here. Here on negotiation needed. I'm going to wait for 5 seconds before sending it to the other side. In 5 seconds, most probably all the ICE candidates will come. So you can add a hacky thing here as well. But this is generally better. Okay, anytime a new ICE candidate comes, let the other party know. And the sender is like, here, if I ever get back an answer, I will call set remote description. If I ever get back an ICE candidate, I will let my peer connection object know the other side has sent me a ICE candidate. This is the sender side. And what is the receiver side? Browser 2 receives the offer from the signaling server. So it received socket.on message. If it received an offer from the other side, it sets the remote description, this point right here. It creates an answer, which is this thing right here. And it responds back, sets the local description to be that answer and sends it to the other side. Everything else that you see here, pc.on ICE candidate, is to let the other side know, okay, here a new ICE candidate has been received. And pc.on track is something you use whenever you receive a track. This callback will be called whenever you receive a track from the other side. And how will the other side send a track? If you go to sender.tsx, pc.add track is all you have to do to send a track. I can also do something like this. Video true, audio true, and I can call pc.add track twice. Okay, I'm going to send the video track as well. I'm going to send the audio track as well, so that the other side can both hear me and see me. We'll do this after we just do the video bit. But let's first finish the video bit. I'm calling add track here. I am receiving a track over here. I need to put it somewhere here in a video element. I need to put it somewhere here on a video element. How can you do that? There are various ways. There is one mentioned in the slides. You can also do what I'm doing over here, which is create a ref to a video element. So if I go here to the top, const video ref equal to use ref null, and then set the reference to be this video element. And here you can do if video ref.current, video ref.current.source object equal to new media stream track or event.track. This will most probably be event. I wrote a few things together, so let me take a breather. If this feels like too much, you don't have to do any of the ref logic. If you go back to the slides, you will notice a slightly uglier approach there, but easier to understand approach. The approach here says, whenever the on track gets triggered, pc.on track, create a new video element, and it just shoves it in the body. This is something you shouldn't do in React. All the DOM manipulation should happen via React, and you should never call append child. But if the ref thingy seems a little difficult to understand, we create a video element and we shove it in the body. and then simply called video.sourceObject to be new media stream, and then in an array we send a single track. This is because there's a concept of streams and tracks inside the browser. You can have a single video object which will have a single stream which can have two tracks, an audio track and a video track. So this is just a browser concept. A stream can have multiple tracks, which is why if you look here, I pass it an array over here. If I get back the audio as well eventually, I can basically do something like this: video.sourceObject.add track, the audio track as well, and then the single stream will play both audio and video. But let's not go there just yet. Let's see if this works or not. Let's see if we're actually able to see the video on the other side. Let me also use this ugly logic of appending the video and not do the ref thingy that I was just doing. Even though this ref thingy is the right way to do this, and you shouldn't be shoving things in the DOM just like we are over here. Append child this, and then video dot source object equal to this, maybe video dot play. This is how I've changed the PC dot on track. Again, this isn't right, and we will eventually, whenever we create a PR on the chess repository, do it right, and have a video element over here rather than shoving it in the DOM like this. But just to see if it works for now, let's do this and see if it works. Most probably should. If not, then this will be a very hard debug. But let's see. Send video on this side. If I go to the other side, I see it. So yeah, that's pretty much it. That's how you do WebRTC. Was it easy? No, it's never easy. It's the good thing is this is all you have to do. If you understand everything that was done, then you're good to go. We basically don't need to learn anything else to do peer-to-peer video anymore. You can build on top of whatever has happened. As you can see, the video is slowly growing up, because whenever you create a WebRTC connection, you first send small video and then slowly it scales up. If I go to the internals, you will see, in the stats the video, wherever the incoming video is, its width is slowly going up, which is the same change you see over here. But that is how you do peer-to-peer video. How many of us understood it? Of course, I will recap it after this, and it was a lot to chew in one class. But do we sort of understand it's a offer, answer, on negotiation needed, add ICE candidates? So the 4 things that we sort of learned. Okay, pretty good. Not too bad for, a heavy class. 74%. Let me recap everything. And of course, if you want to try it out locally, all the code is here for both creating the front end and the back end, and you can do it. But let me, a few questions you might have is, how can the sender also see the video? Very easy to do, right? You can very similarly shove the video on the sender side as well. You have the stream over here. So, all you have to do is something like this. Okay, video, create a new video element and set the stream to be this stream that you got from here. Document.body.append child. Yeah, create a video element, append it to the DOM, and set the source object to be this stream that you created over here, and that will show the video on the sender side as well. So if I now refresh sender and receiver, if I click on send video on the sender, sorry, the audio played as well because I set audio true over here, which means this stream has both my audio and video. And if I put it here in the video object, it sort of started to play the audio as well. So you get the idea. That's how you can do it on the local side, and this is how you can do it on the remote side. Let's go through all the steps one more time, and then I will share some hints as to how you can do the rest of these things. But I will also probably create videos to do some of these assignments. What are the assignments? Okay, you have the basic boilerplate code. Maybe you don't understand a lot of this. It is fine, but you have the basic boilerplate code to do a one-to-one call. How can you produce to multiple people? How would the backend change now? The backend now needs to have not a single receiver socket. If let's say you need a single sender to send video to multiple receivers. Right now, if there are multiple people that join, only the last receiver will receive the video. If I click on send video here, first person doesn't see it, second person doesn't see it. Last person should have seen it, but is not seeing it because the backend overrides. If you go back to the backend, index.ts, it overrides this receiver socket variable. So how can you create this to be an array? And when this does become an array, how does the client side logic of the sender change? Because now sender needs to create multiple peer connections, one for the first user, one for the second user, one for the third user. So this logic will become extremely convoluted. This is one of the reasons that libraries like Peer.js were introduced, which are still peer-to-peer, which still do all of these things we're writing here, but they hide a lot of this WebRTC API stuff from you. So if you ever want to just do this in a slightly easier fashion, you can use Peer.js, which under the hood will create all of these things for you. You don't have to write them, but this is how you do it from scratch. Do you eventually use peer-to-peer? No. As I said, SFU is the most commonly used architecture. And when you do use an SFU, for example, let's say you use the MediaSoup library to create an SFU, a lot of this complexity is hidden from you. MediaSoup has its own set of complexity. If you open the MediaSoup GitHub, you will see this architecture, which is very difficult to understand. So it has it, but it hides all peer connection objects from you. There is no concept of a peer connection object. They've hidden all of that for you, and they've given you something else like producers and transports that you have to deal with. But yeah, that's a brief. Now let me recap everything we've done once, recap the code once, and then I will answer questions. Before the recap, are there any questions that people have generally? How can we add accept or reject logic? Oh, accept or that's not WebRTC logic, right? That simply needs to be, okay, whenever the first side tries to initiate a connection, the other side can block it. And on the receiver side, just don't create an offer. If this user wants to block the object, whenever you receive an offer, here ask the user, alert the user, do you want to connect to the call? And if they say no, then just return. Don't do any of this. That's at the application level. That has nothing to do with the WebRTC stuff. Why do we need SFU architecture when doing Omegle, just doing peer-to-peer, because there are just two people involved? That's a good question. Answers are, if you want to do recording, you won't be able to do it in peer-to-peer. You need your own server in the middle. And secondly, a lot of times reliability. Peer-to-peer connection, they're a lot of times harder to discover. Two peers connecting, one in Roorkee, one in some village, connecting to each other is much harder than if you have your own SFU in the middle. Number 3 is you can see each other's IPs. If you are creating a direct P2P connection versus if you have an SFU, all of that gets hidden. So those are the reasons you might want to use an SFU. Generally, also it's just easier / not easier but better. If you're creating Omegle, why is it better, Kirath? Yeah, the 3 reasons that I gave you pretty much. The downside of creating an SFU though is that it gets expensive, and you have to have your own server. Why do we need ICE candidates? What are you mean the third message? Yeah, so that's a good question. What you want is that both the parties create a connection immediately. But if more ICE candidates come eventually, you let both the sides know, okay, here is another ICE candidate, here is another ICE candidate, which is why, as more and more ICE candidates keep trickling in pc.on ICE candidate, you just let the other side know, hey, here is another ICE candidate that came. Here is another ICE candidate that came. So that slowly all the candidates go to the other side. Cool. Alrighty, no questions related to the class. Happy to answer all the questions. Other questions on the other side. Can we get synced media? For example, video in this case, assuming sharing 760 FPS, if both sender and receiver are on the browser, as the users may be using React app, because according to Curious for WebRTC, we need to do some network operations in order to get low latency, like creating a port for P2P and some network optimization, etc. And we can't do that much control while in the browser as user. I guess your question is, can you sync media if both sender and receiver are on the browser? Syncing media is a whole different question or / research problem in itself. Most of the times, even if they are not synced, the audio and video are so close that it creates an illusion. The person, your mind is able to, even if there's a 50 millisecond, 100 millisecond delay between audio and video, your mind is able to create an illusion they're going together. Also, if you ever attach on the other side, so you can do one of two things when audio and video both come. You can either create basically a video tag and an audio tag, or you can shove both of them in the video tag. When you do this, when you shove the video and the audio in the same video track, is when, syncing is not an issue, but yes, syncing does remain an issue, and, is a challenging problem to solve unless you go very low. And, look at the frame numbers, things like these. What is the criteria for referral? Okay, I've asked this a few times. Criteria is a lot of so the thing that we look at is any PR. So just send your PR to Rookie. If not Rookie, Akash is also a moderator now. I think the name is Akash. My phone is dead. We'll announce. There's another moderator now whose sole responsibility is this, to find the top people to refer. So you should ping them. I will announce today who that person is, and just send your GitHub contributions, your GitHub, and salary expectations to them. Alrighty, coding part is done. Pretty much everything is done. I will just recap it once and then take questions. To recap, what are the steps you have to do? These are the steps you have to do. There is one thing missing here, which is the add ICE candidate method, but everything else is usually this. When two people need to talk, when you bring a third person in the picture, then you need to repeat all of these steps for person 1 and person 3 as well. So when you add another sender, another receiver, let's say, then you have to create another peer connection object, pretty much do everything from top to bottom again between person 1 and person 3. If you add a fourth person, then you need to do all of these steps between browser 1 and browser 4. So all of this code that's written from top to bottom, or steps that are written, need to be done between all the parties that need to exchange media, or in this case, send media from browser 1 to the other side. What are the steps? Initialize a peer connection object, the thing that was done when the user clicked on the start video button. Whenever the user clicks on this button, the first thing that happens is you create a new peer connection object. You say, if ever negotiation is needed, if ever both the parties need to exchange, create the offer, set the local description, and let the other side know, okay, hey, this is my offer. Anytime an ICE candidate is added, let the other side know, okay, a new ICE candidate has been added. Please set it on your side. And for the sender, if you ever receive the answer, you set the remote description to be that answer. If you ever receive the ICE candidate, you call pc.add ICE candidate. You add that ICE candidate on your peer connection object. Lastly, on the sender, we actually created the stream by doing a navigator.mediadevices.getUserMedia. Similarly, you can get the screen recording as well. There's a very similar API, navigator.display, get display device, something like that. You just Google it. But yeah, that's how you get the screen share in case you want to, send the screen from one side to the other side. Let me just do it. Const screen equal to await navigator. Get display media. So if I just replace this with this, what did I do? I replaced get user media with get display media, and now the thing that will get streamed would be my full screen and not my camera. If I now go to /sender and /receiver on the other side, and if I click on send video, it asks me which screen do you want to stream. Let's say I say Accelerator, and then now if I go to the receiver, I don't see the video, but let me play it again. Document dot query selector. There you go. If I play it again, you will see the Excel draw that I had on one side is getting streamed over here. How did I know that I had to play? Because this is a common problem that happens whenever you, especially the way we are doing it, we're shoving it in the DOM. A lot of times, you have to recall play whenever a P frame comes, whenever a full frame comes, which is why I knew I had to do that. And now you can see I'm streaming Excel draw, which is, this website right here over to this browser right here. By just changing, the client side API here by calling get display media rather than calling get user media. And all I have to do is call pc.addTrack. That is all that happens on the sender side. What does happen on the receiver side? Number one, the receiver will receive a create offer message. It means I now need to create a new peer connection. I have now received an offer from the other side, which means someone is trying to create an offer, probably trying to send me some video. So I need to create a peer connection object here as well. Set the remote description. Anytime I receive an ICE candidate, I need to send it back to the sender. Anytime I received a track, I need to put it on my DOM and I need to respond back to this answer by calling answer equal to this thing, and then doing a pc dot set local description and letting the other side know the answer. Yeah, pretty much the same thing. I think I'm covering the same thing thrice now. Yeah, and if you look at this code right here, it's the same thing minus the signaling, which means the same thing minus any WebSocket logic to send data from one side to the other. It just sends the data from this browser to this browser itself. If you look at it, I initialize two peer connections in the same browser. So it's not like I create a video and put it in two elements. I create a video, I create two peer connections, I send video from one peer connection to another peer connection. If you look at it, I call pc1.add track somewhere. pc1.add track. There you go. They call add stream, which is another API. You can call add track or add stream. Add track is the more preferred one. That's what I'm calling on this. And then, they'll probably be on track somewhere. pc2.onTrack is what, gets the track and puts it here. So this is a non-signaled version of the same thing. If you look at this code from top to bottom, pretty much reach the same state. We have written a more signaled version of the same thing. All right. That's last recap. Now I'm going to open up chat. Class is officially over. But as I said, there are a few assignments. I will try to do some of them as well. They will get more and more convoluted. So it's just easier to use an SFU, even, generally, because the API is much easier to understand compared to, this thing. They're like, as you write this, right, you'll understand how complicated this becomes. If you want to send data from one sender to 3 receivers, you pretty much have to rewrite this code. As in, this code needs to run for all 3 of the receivers. You need to create a new peer connection for all 3 of them, which means whenever they respond back with an answer is also you need to find the right peer connection and call the set remote description on the right peer connection. So you'll see this gets very complicated very quickly. If you ever want to do two-way communication, then whatever logic you've written here to create an offer in the sender, all of this logic, it needs to be written on the other side as well, because the other side also wants to send you some data. You need to have 4 peer connections all in all. Right now we had 2, right? If I open about WebRTC, you saw 2 of them. If both the parties are sending each other data, you'll have 4 of them. One for sending and receiving, and one for other side sending and this side receiving. So this gets very complicated very quickly, which is why, as I said, PRJS makes it very easy, hides all of this complexity from you. Under the hood does the same thing, but makes your life very easy. You just have to become a peer in a room, and then it does all the peer connection creation for you. But yeah, generally, if you want to do this, just use an SFU. That's the right way to do it. Alrighty, opening chat. Any questions? These are the assignments for this week. I'll try to solve some of them myself as well. And I'll create a PR in Chess with MediaSoup and WebRTC in a single room. How WebSocket connected to camera hardware? WebSockets are never connected to camera hardware. Your browser is. Your browser can access your camera, and it'll give you a stream. You can forward that stream to the other side, but WebRTC or WebSockets have nothing to do with the camera. WebRTC can also only be used to send data on the other side. It is just that your browser does have access to your camera, if you provide it permissions, of course, if you allow it on a specific website. And then that stream can, through very simple APIs, be forwarded to the other side thanks to WebRTC. But WebRTC doesn't have access to your camera as such. Will WebRTC add value looking for SD roles? If you're applying to a very niche role, then yes. What are these companies, Harkirat? Any WebRTC company that you can pull from 2022. I named a few the other day. I can name a few right now. There is Tite, there is 100ms, there's LiveKit, there is Hopin, there is StreamYard, there is Restream. So, all of these companies, there will always be a video role over there. Look at the jobs role. I'm sure there is like at least one, senior video engineer role. But, what we've learned isn't enough for a senior video engineer. It is great for, if you want to apply there as a full stack engineer and show some interest in WebRTC, but this isn't how WebRTC is done in these companies. What is missing? The SFU logic is missing. Basically, using an SFU rather than doing P2P WebRTC. So if you learn that and then apply, I know a few companies where it should be a easy-ish hire. GatherTown is one such company. If you go to GatherTown, you go to the jobs portal, I think they had, at least the last time I checked, they had 2 video engineer openings. But you need to be good at MediaSoup or LiveKit. Only then does it make sense. Otherwise, don't spam. Nothing will happen. Why my receiver is not working? I've copied from the website only. Most probably, try doing this. Go to your first debug like this. Go to about WebRTC. Check if there is inbound video on one side. One of them will have outbound video, one of them will have inbound video. Make sure there is inbound video coming. Then number 2, do this. Go to receiver.tsx and wherever you're doing video.play, do this. Set timeout. Video.play. After maybe 1 second. Then it should work. If that doesn't work also, create a video.controls equal to true. This should create like a play icon on top of the video. Click on play and that should start it. How and when on ice candidate is getting called? On ice candidate gets called whenever the stun server responds back with some ice candidates. The stun server, if you go to stun WebRTC test, if you go here, if you click on gather candidates, you will see they get gathered slowly. If I click on gather candidates, first this one came, and then eventually after some time this one came. Let me do it again. All of them did not come immediately. So ice candidates slowly trickle in, and when this ice candidate came, then on ice candidate got called with that specific candidate. And then when this one came, then on ice candidate got called with the other ice candidate. Of WebRTC, how template works. What is this? How temp mail works. Or you're asking how does this work? I have no idea. Never thought of it. Good thought experiment though. Please explain ice candidate. Most probably they have an SMTP server where they randomly generate. They have, when you go there, they have a random this thing hash created for you, and then whenever you send an email, it is received by an SMTP server that sort of forwards it to you. That'd be my guess. Please explain ice candidate exchange part again. How to screen share. How to screen share is simple. Rather than asking the user for a camera feed, rather than doing navigator.media-devices.get user media. What does get user media mean? It means get me the user's camera and their mic if audio was true over here. What does navigator.media-devices.get display media mean? It means get me the user's screen. The user will see a pop-up. The user can select what screen to share. And that is what you get in this stream. That is the only change. Other than that, the API remains the same. You still have to call stream.getVideoTracks or stream.getAudioTracks and send it to the other side. That is how you do screen share. What was the other question? Explain the ice candidate part. So yeah, the same thing I said like a few minutes ago. Okay, ice candidates slowly come in. They trickle in. That is what trickle ice means. So what you do is, if add track is called, then renegotiation will happen. Control will reach here, and both the parties will exchange offers and answers. But it might happen this offer never had the ice candidate because the ice candidate is still coming from the stun server. So what we say is, anytime an ice candidate comes, let's not renegotiate. You can also do this. Whenever an ice candidate comes, don't do any of this. Just renegotiate. That will work as well. It will resend the new SDP which will have the right ice candidates. But it's just better, or smaller thing to do is you don't recreate the whole offer. You just let the other side know, these are some extra ice candidate that just came. I already negotiated with you. We are good. But here is another ice candidate. Use it because I just received it from my stun server. That is what add ice candidate does. Contributions, Vishnu Kumar. Yes, I have sent you and one more person's name to that guy. So there are like 2 people. Yeah, you're one of them. Harkia, how much syllabus of 1 to 100 is left? Now, not a lot. Sort of a lot. Happy to share. I was just doing reconciling it the other day. Basically, a lot of DevOps part is left now. Yes, this is where we're at today. Most probably next week is going to be gRPC and Kafka. And then testing will probably just be an offline video. We'll probably just move to, this side, which means container orchestration, Kubernetes from the week after that. We've already done CI/CD monitoring for maybe a week or 2. Yeah, basically everything until this point is done. Everything after that includes Kafka, gRPC, and then, everything on the right is still left. How does works remote access software like AnyDesk TeamViewer work? Can you explain the architecture? Yeah. So screen share is straightforward, very similar to if they use WebRTC. That's what I've seen in one of these softwares. For example, Browser Stack is a software that lets you connect to some other machine. That's exactly what AnyDesk lets you do as well, right? You can stream the video from another machine to yours. The other thing they provide is when you click somewhere, that click also reaches the other side. So that is some logic you have to add on top. Whatever is the machine on the other side, that is streaming video, also needs to give you permissions, accessibility permissions to allow clicks various places. So whenever you're in the browser and you see someone else's screen and you click somewhere, that click is propagated to that machine, and that's the extra thing that you need to do. That you can do via WebSockets. You don't need WebRTC for that. But the core video stream, at least for Browser Stack, how can you confirm? Just go to browserstack.com and create a new session with a Windows machine and then open about WebRTC, and you should see a bunch of WebRTC stats that tells you. And also they have to do that, right? Anytime you see sub-second latency in the browser, it is WebRTC. That's the only way to do 300 milliseconds, 200 millisecond latency for video in the browser. If there are multiple receivers, how to identify the receiver? So you can have proper user logic, right? How to identify the receiver. So basically, receiver sockets will become an array, and the array will look something like this. Socket, this thing, and then ID, which will be a string. So you'll give an ID to every user that joins. That is how you can identify on the server, or whenever the server sends you back whatever create answer, it will send you not just the type and the SDP, but also the ID of the user that is currently sending you back the answer. So that is how you can, through the messages, send over, this is the user, this is the receiver that is sending the message, this is the receiver that is sending the message. And on the client, it's fairly straightforward, right? Here in sender.tsx, you get back, wherever you get back answer, you can, check if data ID is equal to something, then, that specific PC, but you have to call set remote description. So that is how you would add logic to do multiple users everywhere. For live streaming, UDP is preferred, but in case of cloud recording, sure, TCP preferred. Yeah, that is true, but that's actually fair point. But the sender will need to send data over UDP. You can't really be like eventually the sender will only send you data once, right? It's not like the sender is sending a different video to the recorder and different video to the SFU. The sender is sending a single video, and you want that to be over UDP to whatever server you have, which usually is the SFU. So even though you would want the recorder wherever it is running has TCP video, since the original user isn't sending you TCP, if there is a drop over here, that drop will eventually come over here as well. So it doesn't matter. If you're doing this, even in that case, I said not, but if you're sending the video separately to the recorder, which is a very bad idea, because then your user is sending out two videos, one to the SFU and one to the recorder. But if you are doing this here also, it doesn't make sense to send data over TCP, because but maybe it does, I guess. Yeah, sure. Here you can, the recorder, yeah, you can do that. In fact, Riverside FM does that. If you know Riverside FM, it lets you record podcasts. So here they really make sure that the quality is prime. So what they will do is they will send data over TCP, but they will buffer data here as well on the client. So, if you send data over TCP, what's the biggest problem? The problem is, if 5 packets get lost, you re-ask the client for those 5 packets. And then, it can quickly overwhelm your pipeline. And, you will get, if you drop 20 packets, you ask for those 20 packets, but another 20 packets have come by that point because this is live video. So what they do is they maintain a buffer on the client. They basically local record on the client. So they have a queue of, frames. And then eventually slowly keep sending out frames to the recorder. This is the first 5 seconds and then this is the next 5 seconds. So yes, if you do really want extremely HD video, for example, if you have a use case like this, then yes, you should send video to the recorder over TCP. But usually, in case of Zoom, you don't really expect the user to send out two videos, one to the recorder and one to the SFU. You expect the user to send a single video to either the other peer or to an SFU, and from here the SFU does the recording, and here you would expect the user to send it over UDP. What will happen if we don't do the ICE thingy in the code? It might work, it might not work. You don't need to do the ICE thingy if you wait for 5 seconds here. Basically, if you add a timeout here, then in 5 seconds most probably all the candidates will come. So your offer will have all the right ICE candidates. So you don't need to do it. If you put a timeout over here, yeah, that's probably the ugliest way to implement this without having this. But if you just get lucky, okay, by the time on negotiation needed was called, all the ICE candidate had already come. So your offer, when it is generated, it will have all the right ICE candidates. So if you're lucky, then you don't need this. But if your stun server is really far away, if it is taking a long time for them to come back, then unless you do this, the other side won't see you. It will not have the right ICE candidates to be able to discover you. All right, let me open one more time. Any more questions, guys? About the job in WebRTC class, I DM regarding this. Let's see, what is your message? Where did you DM? Can you put the message here again? When we do Kubernetes, probably in 2 weeks from now. Can you put the message here? What's the message again? Here, covering the big data stack. We will not be covering the big data stack. Oh yeah, I remember. We should probably, I'll talk to you. You have my WhatsApp, right? Just ping me there. PR review when? Most probably coming Friday. I will try to do it Wednesday, but most probably Friday. Next week is packed. Why can't we directly send the offer? Why local description is required? Referral required. Oh. Yeah, for referrals, just ping Akash or whoever the new moderator is with your PRs or something close and your salary expectations. You're in NYU, most probably your salary expectations are going to be slightly higher, so it'll be hard for us to refer in the pool of companies that are purely hiring based on arbitrage, but still let your details known. And what was the other question? Why can't we directly send the offer? Why local description is required? I guess your question is which is something I mentioned yesterday as well, is why do you have to call set local description here? And the answer is you have to, unless you do this, whatever is the offer that has been created, whatever are the new ICE candidates that are being added, whatever is the new media lines that you've added, will not get set even on your local description. I totally understand. If create offer was called here, why can't this function automatically set this? Or why? I'm assuming that is why you're confused, or even ask this question. Why do I have to explicitly set local description? And the answer is just that you have to. Akash here. We'll release another Google form for bounties for top contributors. Please ask folks to fill bounty forms and keep around contribution forms. So there is a bounty forms that's going out. Anytime you create a PR and that has a bounty attached to it, you have to fill that form so that we have your details to pay out. And what else did you say? We'll release other Google forms about. Yeah, so just fill that out, and that's the easiest way for us to filter out the top contributors. What is the difference between throttling and rate limiting? In case of video, it means something else only, but rate limiting, I hope you understand rate limiting by now. If a lot of requests come, you stop requests after, if a user sends more than 100 requests every 10 seconds, you stop any requests coming after. Throttling is, you hold it. You're like, okay, slowly, I will respond to you, all of your requests, but slowly, I will throttle your requests. So for rate limiting, you block the request. That's probably the easiest difference between, throttling and rate limiting. What are the project students who have enrolled to HANA Library can contribute to? I mean, right now we only have 3. I'm thinking of adding more so that, if we have people can distribute across projects. I'm not getting the time, but right now there are 3: CMS, Daily Code, and Chess. Can you please explain this a bit? What exactly the ops pipeline means? The deploy just to Kubernetes makes sense. ops pipeline means writing all the infrastructure, not infrastructure as code, writing all the Kubernetes YAML files for the service and the deployment, and putting them in the code base. That's what the ops pipeline. Basically, create an ops folder inside which you put all the YAML files for Kubernetes, and write the CI/CD pipeline that redeploys in case there is any change over there in the number of replicas or something else that you change. That's pretty much what I meant. What I did, I tried to understand the architecture of Judge Zero and plan some auto scaling policy with horizontal scaler in Kubernetes. Sounds good. What did I get from it? Works with the Redis queue. I would have assumed they'd use some sort of a queue. Scheduler assigns it to the worker. No idea what that means. Stores the submission in Postgres. Sounds right. Build on Ruby on Rails. That is correct. We'll try to make this work in my Kubernetes. So yeah, basically the thing that was expected here was create a folder called ops. Inside this, create a folder called Judge Zero, and then shove all the Kubernetes files there, and then write a CI/CD pipeline that deploys it to our cluster in case there is any change in those YAML files. That's it. Does Google Meet, Zoom, Teams use this? They don't use P2P. They use NSFU, something we discussed yesterday. Most probably have their own in-house SFU. Zoom probably does. Probably so does Google Meet. We can get ICE candidates of a browser from a turn server and send the ICE candidates to the browser from Siglink server. You set the browser to relays info through the turn server. So ICE candidate contains the address of the turn server as well. That is correct. Browser 2 tries to reach the browser 1 with ICE candidates of the IP itself, and only when it cannot do it so, it resorts to the turn server's IP address. That is correct. If yes, then why do we even need a turn server? Why can't you can just use a turn server, but going through a turn server means an extra hop. If there are two people, that is a good question. Firstly, each ICE candidate has a priority, and usually the priority of the turn server is much lower. You first want to try to connect directly. Only if it doesn't work do you connect through a turn server. The problem is turn servers, if there are two people, and if I tell you, they're both in India and they can directly connect to each other. They're both in Jharkhand only, the same city. Then wouldn't it be nice if they can, directly talk to each other? If I have this phone and this laptop, they're on the same Wi-Fi. Wouldn't it be nice if the latency will be almost zero if I'm talking here. But if you force turn, you can also force turn. Whenever you're writing, you can pass, force turn here. This is my most popular Stack Overflow answer. This is what got me over the hunch of now I can downvote as well, which is how to force peers to use turn. Whenever you're creating the RTC peer connection object, you can set ICE transport policy to be equal, and what that will do is it will ignore all the non-turn candidates. So you can always force everything by turn. Why should you not do it? Because two people connected directly to each other is much better than data going through a US server, let's say a server that's in the US, because both the people might be in Jharkhand, so it's just easier for them to directly talk to each other versus go through a turn server. Can you still go through a turn server? Yes, you can, but you should first try connect directly. If it doesn't happen, then of course you should fall back to a turn. Alrighty, last set of questions, guys. Alrighty, mine is half red. What does that mean? Off topic. I have learned the basics of Web3.js and Anchor. How can I proceed further? Create a few contracts, simple ones, understand the more complicated ones. Look at Drift protocol. Their code is open source. It's a DEX. It's a DLMM. It also has an order book. I think all of their code is open source. Look at it. What exchange website do you use to swap tokens? I use DEXs. I don't have any tokens on exchanges. Yeah, most of it I have it in cold storage, which means I use a DEX. On ETH I use Uniswap. On Sol I use Orca or Jupiter. I have contributed in two YC startups on GitHub from December to February. Founders weren't hiring from India. How should I proceed further? I've seen this commonly. They're like, for some reason they feel like they need to sponsor the visa. So maybe tell them this is a remote role, offshore engineer. Be explicit about it. Here are you hiring offshore engineers? What's the right way to say? Cheap offshore engineers. Senior devs from India, you have to find a good term for it. But basically, that's what happened with these guys. So I was talking to a YC company and talked to them, and they said, we would love to hire, but we don't have visa sponsorship yet. And I said, okay, chalo, koi baat nahi. Then I later realized that, they probably felt I'm trying to refer someone to, for them to move them to the US. So just be explicit about it. That's the only thing you can do. If they're still not hiring, they're still not hiring. There's nothing you can do about it. That will be true generally for a lot of, early stage startups. So they'll be like, nahi, we don't want everyone to be on site. So you have to find the right companies that do hire remotely. The Notion doc in the browser named Sujit is half read already. Oh, there's more. Unusual thingy. How is your opinion on creating a repo for Rust-based execution engine, as we have a Rust bootcamp, or something like a common worker and a scheduler with a DB? Workers and schedulers auto scales based on requests. My only question is, why do you need Rust? See, in the end, Go is probably the right language to choose here. Why? Because Docker is written in Go, if I'm not wrong, and Go has very simple APIs, or crates or modules to directly talk to Docker, and we'll most probably need some sort of a Docker orchestration here for us to run other people's code. So if you have to pick a fancy language, pick Go, else just go with what we have already, and orchestrate containers via Node.js. Why? Because Judge Zero have the same image for all the things, and it's a bit heavy, which is why cost us really bad mostly. This is a good idea for customized one. Build it in Rust if you want to learn Rust. I'm just saying there might not be any benefit over, because there won't be anything happening in Rust, right? As in, there won't be a lot of lines of code of Rust running, other than orchestrating Docker containers. Start a container with the user's code, and then wait for the response and get it. So yeah, try it, but unsure if it's needed or it's the need of the hour. But if you think it'll help you learn, you should do it. You missed the stream where you reviewed 2 PRs for pending for the past 2 weeks. Every PR is pending for 2 weeks because I've been a little busy. But so I'll look at them together. Let me just bookmark yours though, in case I forget. This is a good PR, by the way. Yeah, this will also change a bit, because most probably all the problem statements will go into a different repository, and all the test cases as well. We'll most probably not be storing all the test cases in the database, because test cases are really long. Sometimes 10 is per 5 lines of inputs, so it doesn't make sense to store it in a database. So basically, after I merged in Nimitz PR, I realized we might have to change the architecture a bit. We might not be storing all the test cases in the database. So we have to change a lot of things there. But the PR is right. Good need of the hour. I just need time to review it. Alrighty. With that, should we call it, guys? What's the humble salary expectation for remote job? 20 to 30K is fairly good if you're fresher or 1 year experience. If you have 2 to 3 years of experience, then you can touch 50K. Anything above it is not humble. 50 to 70, anything above 70 is definitely not, then you have to have some, then salary is not your edge. It's something else. 3 years experience. Could you please help me how to get Node.js React full stack remote job? I'm comfortable with Node.js. Yeah, the best thing you can do is contribute. That's the easiest way for me to pull someone to refer. Look at my portfolio. 2 weeks pending. Can you please set some Web3 project ideas? I'll probably create a video soon enough for Web3 project ideas. I also have the Web3 bootcamp video part 2, where I cover a bunch of use cases, building those use cases, like crypto use cases, building those use cases, what a project idea is, right? Cool. Alrighty, guys. With that, let's call it. Can you explain the video track concept and how it works? Okay. Last thing, and then I'll call it. Video tracks, generally, this is not WebRTC specific. Whenever you have any video, specifically live video, or actually any video, but most specifically, if you just talk about live video, if you ever get the camera stream of the user here, if I go to meet.google.com, when you see my camera screen over here, where is the check my hair screen? Let me join from another tab. When you see the screen over here, right now there is no WebRTC connection. I'm still on this screen. I have not yet joined the session, right? Even on this screen, if you look at the video element that's present here, if I do a document.query selector video dot source object, you will see it returns something. It returns a media stream. This is a construct / variable that the browser provides you, that every video that you see over here has an associated media stream. And every media stream has a video track and an audio track. A single media stream could have multiple audio tracks, and usually it has a single video track. If I do a get video tracks on this, it returns me a single video track, which is pretty much this track right here, and I can use this video track, for example this thing, to create another video if I want over here. If I want to shove another video here, I can get the track like this, const track equal to document.querySelector video.sourceObject.getVideo tracks of 0, and then I can const new video element equal to document.create element video, and then document.append child new video element, document.body.append child new video element, and then new video element dot source object equal to new media stream track, new video element dot play, and that should have started a video somewhere here, wherever that element is shoved. Let's see. But basically you get the idea. It's not a WebRTC concept. Streams and tracks have nothing related to WebRTC. It is just that the WebRTC APIs, if you ever want to send video from one site to another, you call pc.addTrack on one side. Here I am going to add this track to the peer connection object. Whoever is the other side will receive it in the pc.onTrack, which is this callback right here. It will receive it in the event.track variable, and you can just put it in a video element and just play the video. That's how you get the track on the other side. That is what tracks and streams mean. They are not a WebRTC specific concept. Any video that you play, specifically if live video you play, even normal video if you play, but like becomes tracks and streams are something you worry about, specifically when you reach WebRTC or live video. And what do they mean? Stream means a combination of a bunch of tracks that you attach to a video element, and these tracks are like individual video tracks, audio tracks, things like these. All right, that's the difference between video and audio tracks. With that, let's end it, guys. This time for real. I'll see you guys next week. Bye bye.